Hello all. Today's session is about irrational numbers. Before learning the irrational numbers definition, let us recall the rational numbers. Rational numbers are the numbers which are written in the form of p by q, and where q should not be equal to 0. Irrational numbers are the numbers which cannot be written in the form of p by q. These numbers are called as irrational numbers. You can quote root 2, root 3, root 5, root 7. All are irrational numbers along with pi. Pi is also irrational numbers because the value of pi is 22 by 7. If you divide 22 by 7, you will get the repeated numbers 0.1011, 0111, 01111, 0111. In the same way, the numbers continue. Here, this type of numbers are considered as irrational numbers, and these irrational numbers cannot be written in the form of p by q. Let us see the exercise 1.2, where there are some statements are given. You have to justify your answer. Every irrational number is a real number. Real number is a set of numbers where it includes rational and also irrational. Here the question asked is every irrational numbers are real numbers. Yes, every irrational numbers belongs to real numbers. Hence the given statement is true. Let us write the answer in the statement form. Solution: true. The real number is made up of rational and irrational, isn't it? Real number is made up of rational and irrational. The real numbers, how you can define the real numbers? Real numbers is either rational or irrational. The real number can be rational or real number can be irrational. We can say that every real number is represented by a unique point on the number line. If you take the number line, every numbers are represented with a unique point. No numbers are same. That is the meaning of real numbers. Every point on the number line is represented by a unique real number. See, if you mark or if you represent any number, they are unique. They are not same as the before number, or they are not same as the consecutive number. Every number is unique as its own. Next question. Every point on the number line is of the form of root m, where m is a natural number. Where m is a natural number. Natural number means m is equal to 1, 2, 3, 4, etc. Now, here in number line, even you can represent the negative numbers, even you can represent 0, and even you can represent the root numbers, isn't it? Here you should understand what is root 1. The square root of 1 is 1. Square root of 2 is 1.41. The square root of 3 is 1.7. The square root of 4 is 2, so on. This natural numbers indicates only the positive values, but even negative numbers are represented on the number line. Hence, the statement is false. The statement 3. Every real number is an irrational number. Real numbers is a set of numbers which includes rational and irrational. Here, the question is every real number is an irrational number. No, because the real number may be rational. The real number may be rational or real number may be irrational. Every real number is need not to be irrational. It may be rational or irrational. Hence, the given statement is false. The given statement is false, and we can conclude The real number consists of both rational and irrational numbers. For example, if you take 3, 3 is a real number but it is not irrational. 3 is rational. Why? 3 can be written in the form of P by Q, that is 3 by 1. Hence, 3 is a real number but it is not a irrational. And one more thing you should understand, the reverse of the statement is true. Every irrational is real. See, every irrational is real, but every real is not irrational. It may be rational and irrational. Question number 2. Are the square root of all positive integer irrational? If not, give an example of square root of number that is rational. Here, please understand the question. Are the square root of all integers? First, you have to understand what is integers. Integers means it is a set of numbers which includes positive and negative numbers along with the 0. The set of all positive integers. Take root 1, that is 1. Root 1 is rational. Take root 2, it is irrational. If you take root 3, again it is irrational. If you take root 4, it is 2, that is rational, and root 5 is irrational. Hence, the statement we can state it as no. The square root of all positive integers are not irrational, because if you see the list, there are some even rational numbers are there and even irrational numbers are there. You can say that sum of the square root of positive integers is rational. Sum of the square root of positive integers are irrationals. So we can write no. The square root of all positive integers are not irrational. If you find my videos are useful, please don't forget to subscribe and share to your friends. Thanks for watching.